Hey everyone, Mike here at the DevOps Lounge. Now you might be wondering why I'm now called the DevOps Lounge when in fact it was previously called the Cloud Coach. It's because the channel is going to be getting rebranded to the DevOps Lounge in order to match the Discord server that I've set up, which was originally also the Cloud Coach. And I'm actually rebranding so that I can create more of a open community that's more about the community and less about me as an individual. So you'll see a lot of rebranding coming up soon, and we'll be switching over to the DevOps Lounge. So what's today's video about? Well, I want to talk today about taking a Terraform state and splitting it up into multiple states. And there's a good reason why we'd want to do this. The first reason is speed of execution. So we want to take our Terraform state files, which can be extremely large. In fact, I currently work for a client who has one environment, and the very basic version of that environment has over 300 resources in it in order to build subnets and route tables, security groups, transit gateway attachments, and lots of little tiny components that make the state file relatively big. And it's a very good practice for multiple reasons, which I'll go into, to actually split that state file up into several states that are isolated from each other. So that means that you would have code in one location that produces one state file, and that code could handle the networking side of things. And then you have another bit of code with another state file that produces another state file for you, separate from the other state file. And that could be the compute side of things. So that could be all your EC2 instances, your ALBs. It could be anything to do with the actual compute layer. And then you could have a third state that produces a third bit of code that produces a third state. That could be for your databases, your caching layers, your CloudFront, and lots of other different things that you can do. But the idea is that you want to take these large state files and split them up, because if you have a state file, like I just said, with hundreds and hundreds of resources in it, every time you want to change a little tiny part of it, for example, you might want to add in a security group or change an existing security group, the whole Terraform's got to run the whole thing. It's got to go over to AWS or Google or both, and it's got to work out the current state of everything within the provider, up in the cloud provider, and then it's got to match them to what's in the state file, and then build the directed acyclic graph in order to work out, well, what's changed in the code, and that takes longer. If you split it up, so let's say we've got 300 resources and networking makes up, say, 100 of them, and then the compute takes up 50, and then the data takes up 50, and then another 100 is for security IAM policies. You could have 4 states there. And that means that if you just need to change networking side of things, then what you can do is just go to the networking code, make that small little change, and then Terraform only has to refresh and understand the current state for 100 resources, not 300, and so it executes faster. Another benefit that you get from splitting up the state files is security. So if you imagine within most organizations, we have networking teams, very large organizations especially, we have a networking team, we have a database team, we have DBAs, we have developers, we have operations, and so we usually have a cybersecurity team as well. So what you can do with state files is when you've split them up, the state files, once they're split up, are controlled by separate pieces of code. If you put those, and you should put those separate pieces of code into their own repository, then you can control access to those repositories individually. So anything to do with your IAM policies in AWS, for example, or your Active Directory policies, or your group policies within Azure AD, you can say that only senior engineers can have access to those repositories because they're to do with security. And even then, they only have read-only access. And actually, the only people that can make changes are the cybersecurity team. And you can do things like code reviews and pull requests to ensure that any code that's being written is meeting company expectations at the security level. And then the same applies for the database layer as well. You can say only the DBA team can make writing changes to that repository. Or you could actually say no one can access the repository except the DBAs, and no one can access the network inside of it except the network administrators. It all depends how strict your policies are within your organization. So splitting up our code, splitting up our state files also means we split up our code as well. And that gets us, as I've just said, it gets us faster runs. It gets us that separation of concerns, which is actually a programming concept of keeping code just doing the one job that it needs to do. And we can do that with our Terraform code as well. We can split it up so that we get that separation of concerns. We get our security code, we get our networking code, our data code, and so on and so forth. So they're the benefits of actually taking a Terraform state file and splitting it up. So that's why you would split up a Terraform state file. But obviously we got the question of, well, how do you do it? How do you actually go about splitting up your Terraform state file? So what we're going to do now is we're going to look at a bit of example code that I have here on the screen. As you can see, it's pixelated behind me, but if I switch over to coding mode, you can see here that I've got a VS Code running and I've got some code in here already. So we're going to take a look at this right now. So if we look on the left here, we can see we've got application, networking, and prerequisites. So we'll just have a look at the prerequisites because this is very, very simple. We're going to need an S3 bucket to store our individual state files in. So they're going to be stored remotely. So all this actually does is just has a simple AWS provider, and then it just creates an S3 bucket. That's all it does. It's very, very simple. So if we have a look at the state file here, we can see that it exists on disk. So we're not actually storing this one remotely. And that's just because this is just an example. So this is kind of a chicken and egg situation. We can't store our state in S3 in a bucket that doesn't exist yet. So this prerequisite state here on the left just creates our S3 bucket for us for the other two. And that's all we really care about at this point. If we head up here, or we go up a level, we go to our networking, we can see here that we have our providers. We've got our AWS provider, and now we're actually configuring the networking code to use this S3 bucket that the prerequisites actually creates for us. Okay, and we're creating the state file called networking.tf. So it's going to go in that bucket at the very top, at the very root of that bucket. It's going to create an object called networking.tf. And we're going to be doing that in Sydney because that's where I live. I live in Australia. I live in Brisbane, Australia, but Sydney is my closest AWS region. So that's the networking side of it. And then we've just got a very, very simple application side of it. So we're in the application tier as well. We've got our application provider. And again, we're just configuring the exact same Terraform backend to use S3. We're going to the application.tf key this time. And again, we're in Sydney. So same bucket, just a different file name for the state. So that means that the application state will be separate from the networking state, which will also be separate from the prerequisite state. And so straight away, we've already got these two separate states stored in S3, which means that that means that we have to run multiple Terraform commands, Terraform inits and Terraform applies in order to get these things in place. Now, the prerequisites one actually already exists. So what we're going to do is we're going to look at what we have here on disk. So there's exactly what you've just seen there in VS Code. We've got our application, we've got our networking, and we've got our prerequisites. So before we create the application, we have to create the networking first. And so we can demonstrate that. So if we come in here and we do our Terraform init in order to get our plugins and configure our backend, and then we do our apply, we should see that it comes back with an error. So it comes back saying that, unfortunately, there is no state in that backend. It doesn't exist at this point in time because the application state relies on that networking state to exist. And I'll demonstrate that. I'll demonstrate why in just a second. So if we go back one, so that just proves that the networking has to exist first. So if we pop into here and do a Terraform apply, we don't need to do an init because the code is actually ready to go. So we do our Terraform apply in here, and it's going to add 9 things, and it's a very, very simple architecture, and the actual architecture isn't really relevant to this video, but we just have a VPC, we just have three subnets, we have our route tables, associations, we have an internet gateway, and so on and so forth. So it's really, really simple, and actually none of that really actually matters that much. So I'm going to go ahead and say, yes, here, I want you to create this. So we're going to see those resources getting created, and there we go. Now, we've created a new state. Here, we can see that we have outputs coming directly from the very root of that code. Let's have a look at them. So we come over to here to networking, and we come to these outputs over here, we can see that we have environment name, we can see we have VPC ID, subnet, AZA, and we're actually getting these resources and we're actually outputting them. Now, this is actually really important. So what we're actually going to be doing here is we've created our networking infrastructure, which is going to be stored inside of a state file, which is going to be pushed up to S3. Okay, it's going to be stored up here in S3. What we're going to do from the application side of things, as you saw that error before when we attempted to create the application code, what we're actually going to be doing is we're going to be grabbing that networking state file from S3 and we're going to be pulling data from it. And the way we do that is we rely on these outputs. We need these outputs. So what you have to do in order to make the remote state file accessible by other state files is you have to have outputs at the very root here. You can see here it's at the very root. It's not inside of a submodule. It's not inside of any other module. It's at the very root of this state here. So that means, just as we can see in the terminal here, that these outputs are available now to anything else that can access that state file. So if we summarize, we want to create individual state files because we want that separation of concerns. We want to split up our large infrastructure into lots of little manageable pieces. But how do we make, if we've got it all split up, previously we had a big monolith, didn't we? We had a big, huge amount of code and everything can reference each other. But if we split it up into lots of little pieces, how do we reference the VPC ID from the application state if there's a hard barrier between them? That's what these outputs are about. They're over that way. That's what these outputs are about. These outputs allow anything that can access that state, they allow it to pull the state down, access those values, and then use them as if they were just like local resources. So let's take a look at that now. Now that we've got our network installed up, let's take a look at the application side of things. So here in the application providers file, which we looked at before, we just have our AWS region, we have our Terraform backend configured to use our application.tf, but we want to access the networking.tf. So how do we do that? Well, in this data.tf file here, we've got Terraform remote state. We've got a data block that accesses the type Terraform remote state. We're going to call it networking. We're going to say that the backend is S3 because it is, right? Because we got this backend here. Remember, we configured it S3 and we did the same for the networking module. So our backend is going to be S3 and we're going to configure it with the bucket name, the exact same bucket. And if you remember, the key was networking.tf. So that's the key we're going to access. And this is the region where that bucket is located. So it's going to go to, if you think about the path here, it's going to go to S3 / and then networking.tf. So that's actually what it looks like, the S3 path that it's going to go in and fetch it from. But it doesn't expect to see the configuration in that manner. So we'll just undo those changes. So the application state is going to go and fetch the networking state. But then how do we use it? If we look here in the ec2.tf file, we'll get an idea of how we take the outputs that we have from the networking state and how we actually bring them into our application state in the code. So as I said, the architecture is actually really simple. All we're actually doing here is we're fetching a Ubuntu AMI, and then we're just creating 2 EC2 instances. It's not really that difficult at all. Now it's the subnet IDs that we're actually going to be dragging in from the networking state. So like I said, very simple example, not complicated at all. And you can see here on line 21, you can see that we've got this network ID. And what we're doing is we're using that data block that we defined of type Terraform remote state. We gave it the name networking, and then we're fetching the outputs. Remember those outputs that we created earlier in the networking state? We said that in order to access information inside of that remote state, we have to have those outputs at the root level. Well, now we're accessing them. This is the key part of it. This is where we're accessing them. And inside of our AWS EC2 instance here, we're saying that we want to access the outputs of the networking remote state, and we want to access subnet _AZ _A. You can see that just above my head there. And if I scroll down, you can see B here as well. So we're creating a second instance, and we're also pulling in that value from the remote state called networking. We're grabbing an output called subnet AZB. And so that means that the application state file then becomes dependent on outputs from the networking state file. But once you've got that remote state, once you've actually pulled that remote networking state in from the S3 bucket, you can then access the outputs. And so that allows you to create that separation of concerns without losing the ability to reference things in the different state files. So if we actually go ahead now and we come back out, we come back into our application side of things, and we do our Terraform apply in here. Terraform's going to use that data block. It's going to go fetch that state from S3, and as you can see, we don't have our error. And now we can see that it's actually going to go ahead and add 2 resources, just 2 EC2 instances. This is a very, very simple example. And as we can see, look at the subnet ID, 7, let's remember that E78E. That's the subnet ID for our web AZB instance. And then if we look at here, we've got a second different subnet ID here for web AZA. Now, if we go up to those outputs, there's E78E right here. There's AZB and there's subnet AZA. So you can see there that it's getting those references from the other state. It's getting them from the other state file, which is great. So if we go ahead and say yes here, that will now create those instances in those subnets using the values that are pulled from the other state. So that state file has now gone ahead and been created. So that's now been stored up in S3. And we can see we've got our 2 EC2 instances here. They've been created. They will have been created in the subnets that were created in the networking state. So if we have a look at the code, so if I come out of directory and I just look at that tree structure again, we can see here that we've got little tiny small code bases that manage separate things for us. But if you imagine this on a much larger scale, this makes it much easier to, first of all, identify where you need to be. What is that I need to fix? Well, I need to rename the instances inside of the dev environment. Well, I know I need to go to the dev environment, and they're going to be instances. So they're going to be here at the application level. So I'll go into the application folder, and then I know the EC2 instances. So I'll go into ec2.tf. And then when I eventually make the change and push it, when the CI pipeline runs, because obviously you're using CI/CD, right? It will do the Terraform apply. And of course, we'll get a much quicker, much faster execution. And that is one of the key reasons why we want to split up our Terraform state files. Now, of course, this kind of work obviously is going to introduce some levels of complexity, and I'll show you why. Let's go into the networking state and let's destroy everything. So we're going to do a Terraform destroy. We're going to instruct Terraform that we want to delete everything in here. What do you think might happen? I'm going to hit yes. It's going to destroy the 9 resources that we created earlier. So I'm going to hit yes. What do you think might happen? Well, I'll tell you. First of all, it's going to successfully delete a lot of these resources. As we can see here, it's actually got rid of the route table associations. It's got rid of the internet access route table itself. It's got rid of AZA, so it's got rid of subnet AZA. We can see here it's deleted successfully the internet gateway, the primary internet gateway that we had set up. But what it hasn't destroyed so far is the VPC, and it's still currently destroying subnet AZA and AZB. Now, do you reckon that might time out? Yeah, it will time out. The reason being is because those resources are in use by the application state, because the application state created EC2 instances in AZA and AZB, and there are subnets. So Terraform has now issued a command to the AWS API to say, delete these subnets. And obviously the API is going to come back and say, you can't do that because there are resources relying on those subnets. So how do we resolve that? Well, we built it in 3-stage process, didn't we? We did the prerequisites first, so we got our S3 bucket. Then we did the networking, so we got the foundations we needed. And then we did the application, which then plopped 2 EC2 instances on top of those foundations. And so when we come to decommission an environment, we essentially go backwards. So we've got to get rid of the application layer first, then we get rid of the foundations, the networking layer first, and then we get rid of the prerequisites if you want to delete that S3 bucket, which is unlikely. You tend to want to keep that stuff there. All right, so let's look at actually unfolding all of this then. So let's actually go back into the application side of things, and let's do our Terraform Destroy. So let's actually demonstrate decommissioning this infrastructure and going backwards. So it's obviously a very small, simple bit of infrastructure. So it's going to be quite quick here on screen. So we're just going to delete these two EC2 instances. That shouldn't take too long. And once that's done, when we go back to do the networking side of it, we'll see that we don't actually have 9 sets of resources anymore, because we did actually successfully destroy a few of them. What we're going to actually see is we're going to have about 3 to destroy. We're going to have the virtual private cloud, the VPC, to destroy, and we're going to have those 2 subnets which will now be available to destroy once these 2 EC2 instances have been marked as destroyed, because of course they're not relying on the subnet anymore. So that means that the Terraform can actually release those resources. So that's now finished. So if we go back now to our networking and we do our Terraform Destroy again, we'll see that it'll do a refresh state again, of course. It'll go and look at the remote state of these things, and we can see we've now got 3 to destroy. If we hit yes on this, we should see it destroy the VPC and our 2 subnets, and there we go. So we've now decommissioned that entire environment. And of course, the state files are actually still going to be present in S3. They're just going to be empty. They're not going to contain anything. And so that's what it looks like to take a Terraform state file and break it up. Now, before we go, I just wanted to demonstrate just very briefly what this actually looks like visually. So I've just got a very simple diagram here, which will get a little complicated once we start seeing lines all over the place. But I think hopefully it should help. So what we've got here, we've got our prerequisite state that we talked about earlier. And what that's going to create for us is an S3 bucket up in AWS. Now, what I said is that I'm going to store the .tf state file. I just store that for this one in the Git repository, and I just secure that Git repository. If we move over to the next stage, we introduced our networking environment, didn't we? So we brought our networking state in. So this arrow clearly shows the actual dependency of what direction things go in. And so we've got our networking state, and our networking state is going to create VPCs, subnets, route tables, and internet gateway. It's going to build those things for us inside of AWS. But here's the difference. It's going to store its state file inside of a reference to this S3 bucket. That's why the lines are dashed there, just to say this isn't actually an S3 bucket. It's this reference to this S3 bucket up here. Yeah. So we're creating this reference here to this S3 bucket. So we don't want you to create the S3 bucket and store it in here. Use this background. Let's have a look what we're looking for here. We want to use this, don't we? We want to use this remote state backend configuration in S3. That was what I was just trying to say there. We've got our bucket, we've got our key, etc. So that's what this is. This is referencing this S3 bucket here. So what's the final stage? The final stage is obviously our networking stack here. So we've got our networking state file here, which is producing our EC2 instance. And what we're doing here is 2 things actually. So first of all, we're also going to store, the application's also going to store its state inside of a reference to that same S3 bucket up here. But we're going to also be pulling, as we can see here, we've got a line that draws between this S3 bucket here and this data block. Okay, so we're looking at these 3 things here. That's because what we're doing with the application state, we're actually pulling the networking state out of the S3 bucket in a data block. And we're actually going to reference some of it here inside of this EC2 instance here. We're going to create a reference from the networking stack here. And in this case, it was the subnet IDs that we needed. And then, of course, once that's done, we've now got a dependency on the networking state, which is why when we can't try to delete the networking state, we got that timeout because it couldn't destroy the subnets because the EC2 instances already existed inside of the subnet. So what we do here is we reverse this. We destroy the application state, then we're left with just the networking, then we destroy the networking, and then we're back to square one again. So that's the decommissioning process going backwards. So hopefully that illustration was useful, and hopefully that helps visualize the actual flow of what you need to do. And so just to summarize very quickly, we're going to be creating our state file inside of an S3 bucket. We've got it configured here. There's the bucket name. there's the name of the key, so on and so forth. And then in another state file, in another code base, we're going to go and retrieve that state file from the S3 bucket. And then here in the EC2, we're then going to reference the subnet ID here, data.terraform remote state. So we've got a data block. It's the Terraform remote state. That's the type. We called it networking. We want to access the outputs, and we want to access subnet AZA. So that there is the code equivalent to that entire graph that we saw here with everything in place. That's that reference here going into the EC2 instance is essentially this code here. That's that code right there. And that's how we access the outputs from the remote state. Hopefully that's clear. Hopefully that's simple. If you've got any questions, then we have the DevOps Lounge Discord. I'll put a link in the description, and I'll put a little link here on the video as well. I hope that's been really useful for you. I really hope that you join us on the Discord. It'd be great to hear from you if you've got any questions, any advice that you'd like to give. That would be really, really great. And of course, feel free to just join if you just want to chat with other professionals. Don't forget to like and subscribe to the channel, because that tells me that you're interested in seeing more of this content. And feel free also to join the Discord and tell me what type of content that you'd like to see going forward. Okay, thanks very much. All the best. Enjoy your day.